Hello everyone. And welcome back once again to another interesting video. In today's video we'll discuss about data analysis, like what is data analysis, why is data analysis important, types of data analysis methods, and advanced techniques to analyze data. So if you are ready, let's start today's video. What is data analysis? Although many groups, organizations, and experts have different ways of approaching data analysis, most of them can be distilled into a one-size-fits-all definition. Data analysis is the process of cleaning, changing, and processing raw data and extracting actionable, relevant information that helps businesses make informed decisions. The procedure helps reduce the risks inherent in decision-making by providing useful insights and statistics, often presented in charts, images, tables, and graphs. A simple example of data analysis can be seen whenever we make a decision in our daily lives by evaluating what has happened in the past or what will happen if we make that decision. Basically, this is the process of analyzing the past or future and making a decision based on that analysis. It's not uncommon to hear the term big data brought up in discussions about data analysis. Data analysis plays a crucial role in processing big data into useful information. Neophyte data analysts who want to dig deeper by revisiting big data fundamentals should go back to the basic question: what is data? Unlock new career opportunities with online non-coding courses. Gain valuable skills, explore diverse domains, and excel in the digital era. Why is data analysis important? Here is a list of reasons why data analysis is crucial to doing business today. Better customer targeting. You don't want to waste your business's precious time, resources, and money putting together advertising campaigns targeted at demographic groups that have little to no interest in the goods and services you offer. Data analysis helps you see where you should be focusing your advertising and marketing efforts. You will know your target customers better. Data analysis tracks how well your products and campaigns are performing within your target demographic. Through data analysis, your business can get a better idea of your target audience's spending habits, disposable income, and most likely areas of interest. This data helps businesses set prices, determine the length of ad campaigns, and even help project the number of goods needed. Reduce operational costs. Data analysis shows you which areas in your business need more resources and money, and which areas are not producing and thus should be scaled back or eliminated outright. Better problem-solving methods. Informed decisions are more likely to be successful decisions. Data provides businesses with information. You can see where this progression is leading. Data analysis helps businesses make the right choices and avoid costly pitfalls. You get more accurate data. If you want to make informed decisions, you need data, but there's more to it. The data in question must be accurate. Data analysis helps businesses acquire relevant, accurate information, suitable for developing future marketing strategies, business plans, and realigning the company's vision or mission. What is the data analysis process? Answering the question, what is data analysis, is only the first step. Now we will look at how it's performed. The process of data analysis, or alternately, data analysis steps, involves gathering all the information, processing it, exploring the data, and using it to find patterns and other insights. The process of data analysis consists of data requirement gathering. Ask yourself why you're doing this analysis, what type of data you want to use, and what data you plan to analyze. Data collection. Guided by your identified requirements, it's time to collect the data from your sources. Sources include case studies, surveys, interviews, questionnaires, direct observation, and focus groups. Make sure to organize the collected data for analysis. Data cleaning. Not all of the data you collect will be useful, so it's time to clean it up. This process is where you remove white spaces, duplicate records, and basic errors. Data cleaning is mandatory before sending the information on for analysis. Data analysis. Here is where you use data analysis software and other tools to help you interpret and understand the data and arrive at conclusions. Data analysis tools include Excel, Python, R, Looker, RapidMiner, Chartshow, Metabase, Redash, and Microsoft Power BI. Data interpretation. Now that you have your results, you need to interpret them and come up with the best courses of action based on your findings. Data visualization. Data visualization is a fancy way of saying, graphically show your information in a way that people can read and understand it. You can use charts, graphs, maps, bullet points, or a host of other methods. Visualization helps you derive valuable insights by helping you compare datasets and observe relationships. Types of data analysis. A half-dozen popular types of data analysis are available today, commonly employed in the worlds of technology and business. They are: descriptive analysis. Descriptive analysis involves summarizing and describing the main features of a dataset. It focuses on organizing and presenting the data in a meaningful way, often using measures such as mean, median, mode, and standard deviation. It provides an overview of the data and helps identify patterns or trends. Inferential analysis. Inferential analysis aims to make inferences or predictions about a larger population based on sample data. It involves applying statistical techniques such as hypothesis testing, confidence intervals, and regression analysis. It helps generalize findings from a sample to a larger population. Exploratory data analysis or EDA. EDA focuses on exploring and understanding the data without preconceived hypotheses. It involves visualizations, summary statistics, and data profiling techniques to uncover patterns, relationships, and interesting features. It helps generate hypotheses for further analysis. Diagnostic analysis. Diagnostic analysis aims to understand the cause and effect relationships within the data. It investigates the factors or variables that contribute to specific outcomes or behaviors. Techniques such as regression analysis, ANOVA, or analysis of variance, or correlation analysis are commonly used in diagnostic analysis. Predictive analysis. Predictive analysis involves using historical data to make predictions or forecasts about future outcomes. It utilizes statistical modeling techniques, machine learning algorithms, and time series analysis to identify patterns and build predictive models. It is often used for forecasting sales, predicting customer behavior, or estimating risk. Prescriptive analysis. Prescriptive analysis goes beyond predictive analysis by recommending actions or decisions based on the predictions. It combines historical data, optimization algorithms, and business rules to provide actionable insights and optimize outcomes. It helps in decision-making and resource allocation. Next, we will get into the depths to understand about the data analysis methods. Data analysis methods. Some professionals use the terms data analysis methods and data analysis techniques interchangeably. To further complicate matters, sometimes people throw in the previously discussed data analysis types into the fray as well. Our hope here is to establish a distinction between what kinds of data analysis exist, and the various ways it's used. Although there are many data analysis methods available, they all fall into one of two primary types: qualitative analysis and quantitative analysis. Qualitative data analysis. The qualitative data analysis method derives data via words, symbols, pictures, and observations. This method doesn't use statistics. The most common qualitative methods include Content analysis, for analyzing behavioral and verbal data. Narrative analysis, for working with data culled from interviews, diaries, surveys. Grounded theory, for developing causal explanations of a given event by studying and extrapolating from one or more past cases. Quantitative data analysis. Also known as statistical data analysis methods, collect raw data and process it into numerical data. Quantitative analysis methods include hypothesis testing, for assessing the truth of a given hypothesis or theory for a data set or demographic. Mean, or average, determines a subject's overall trend by dividing the sum of a list of numbers by the number of items on the list. Sample size determination uses a small sample taken from a larger group of people and analyzed. The results gained are considered representative of the entire body. We can further expand our discussion of data analysis by showing various techniques, broken down by different concepts and tools. How to analyze data. Top data analysis techniques to apply. To analyze data effectively, you can apply various data analysis techniques. Here are some top techniques to consider. Define your objectives. Clearly define the objectives of your data analysis. Understand the questions you want to answer or the insights you want to gain from the data. This will guide your analysis process. Data cleaning. Start by cleaning the data to ensure its quality and reliability. Remove duplicates, handle missing values, and correct any errors or inconsistencies. Data cleaning is crucial for accurate analysis. Descriptive statistics. Calculate descriptive statistics to understand the main characteristics of the data. Compute measures such as mean, median, mode, standard deviation, and percentiles. These statistics provide insights into the data's central tendency, spread, and distribution. Data visualization. Create visual representations of the data using charts, graphs, or plots. Visualization helps spot patterns, trends, or outliers that may not be immediately apparent in the raw data. Use appropriate visualizations based on the type of data and the insights you want to convey. Exploratory data analysis or EDA. Perform EDA techniques to explore the data deeply. Use data profiling, summary statistics, and visual exploration to identify patterns, relationships, or interesting features within the data. EDA helps generate hypotheses and guides further analysis. Inferential statistics. Apply inferential statistics to conclude the larger population based on sample data. Use techniques like hypothesis testing, confidence intervals, and regression analysis to test relationships, make predictions, or assess the significance of findings. Machine learning algorithms. Utilize machine learning algorithms to analyze data and make predictions or classifications. Choose appropriate algorithms based on the nature of your data and the problem you're trying to solve. Train models using historical data and evaluate their performance on new data. Clustering and segmentation. Employ clustering techniques to identify groups or segments within your data. Clustering helps in understanding patterns or similarities between data points. It can be useful for customer segmentation, market analysis, or anomaly detection. Time series analysis. If your data is collected over time, apply time series analysis techniques. Study trends, seasonality, and patterns in the data to forecast future values or identify underlying patterns or cycles. Text mining and NLP. If working with textual data, employ text mining and natural language processing techniques. Analyze sentiment, extract topics, classify text, or conduct entity recognition to derive insights from unstructured text data. Remember, the choice of techniques depends on your specific data, objectives, and the insights you seek. It's essential to have a systematic and iterative approach, using multiple techniques to gain a comprehensive understanding of your data. What is the importance of data analysis in research? A huge part of a researcher's job is to sift through data. That is literally the definition of research. However, today's information age routinely produces a tidal wave of data, enough to overwhelm even the most dedicated researcher. From a bird's eye view, data analysis 1. Plays a key role in distilling this information into a more accurate and relevant form, making it easier for researchers to do their job. 2. Provides researchers with a vast selection of different tools, such as descriptive statistics, inferential analysis, and quantitative analysis. 3. Offers researchers better data and better ways to analyze and study said data. So, here's a list of the top 7 data analysis tools in terms of popularity, learning, and performance. Tableau Public. R Programming. Python. Apache Spark. SAS. Excel. RapidMiner. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.